Welcome to our webinar on Electra EMC software. Electra is a software that controls complete EMI and EMS systems. And Electra is the replacement or the successor of the EMC32 EMC software, which has been on the market for quite a long time now. I would like to focus today on automotive features, but also introduce the general features of the Electra software. Why have we launched an Electra software? EMC32 has been in the market now for roughly 20 years. We decided some time ago to build a successor product of EMC32, which is well known. We have thousands of installations worldwide. And the reason for that being that the development platform on EMC, which is based on EMC32, has been phased out by Microsoft, and as the name implies already, EMC32 is a 32-bit application which will obviously not work in future operating systems which focus on 64-bit applications. Now there are two approaches to tackle that. That's first of all, you can just write a new software, which we did with Electra. But you could also just port the code from 32 to 64-bit, which will then end up with a software that is not likely with a high quality. So we decided to do the first approach, write a complete new software based on all the experiences we have made with EMC32. And as mentioned, we've been in this market now for quite a long time. The functionality of Electra is quite similar to EMC32. So we measure EMI, we do EMS, we measure commercial devices, automotive, which we're talking today, military, but also transmitting and receiving devices according to ETSI and FCC regulations. On the slide, we can see the functional overview of Electra. So we start from a planning phase where we plan our tests. We migrate data from EMC32. That's very important if you're using EMC32 today. You manage your EUTs and then basically define your tests in advance. Then you move on to the execution phase. You run the test, and that's where Electra controls all the instruments that are involved in the EMI and EMS system, like amplifiers, receivers, generators, power meters, and so on. We run these tests automatically. But you can also do an interactive test where you do manual adjustments and record points to debug things on your device under test. It's very important to keep an overview of where you are in your test, what is happening now, because tests can take quite a long time. Although we decided to spend much effort on improving the test speed, so we have enhanced the test execution time, using modern technologies which were not available at the time when EMC32 was developed to speed up the execution and also improve the communication to instruments like our receivers. Once you've done the test, we step to the measurement. We go to the analysis phase where you identify critical points in an EMI scenario, for example, or where you do a worst case analysis on several test runs, or simply a 3D view on a measurement of a transmitting device. Once that is done, we go to the reporting phase and create a Word document, a PDF document over several tests, for example, and provide a very sophisticated method to allow you to customize your test the report to your needs. The standards which are supported by Electra, I mentioned it already, commercial, automotive, military, and also wireless devices. So pretty much everything is currently being supported in Electra. There are a minor thing that is not yet available, which will be available in one of the next versions available this year. This is wireless LAN and Bluetooth, so radiated spurious emission measurements on wireless LAN and Bluetooth will be available soon, are not yet available. We have focused first on 5G devices are now working on 2G, 3G, 4G cellular devices, and then we are going to do the wireless LAN and Bluetooth implementation. In general, the radiated spurious emission is a very separate topic. Special measurements with a very high frequencies, wide frequency ranges that have to be covered, but it's similar to an EMI measurement for those who are not familiar with RSE. Okay, so let's take a look at the software itself. I'm not going to show slides. I directly step into the software and show you a quick introduction on how Electra is set up or built, or the user interface, how it works. Those who are using EMC32 should be familiar quite quickly with Electra. We have taken over a lot of features of EMC32 because the experience we made was quite positive and the feedback we got was positive, so we reused some concepts of EMC32. What you see on the left-hand side is a list of elements that are being used during a test or for a test. And this is first of all a device list. That's a list of instruments that are being used during the test, like generators, receivers, amplifiers. The hardware setup, which defines how these instruments are being connected. The test template, which defines the workflow of a test, how a test is being executed, what parameters are used, and which steps we are going through. And finally, in the tests element, we find all the results of a test that has been executed. And these tests are saved or stored with all the relevant data, so you can easily rerun these tests later on. In addition, we have the report templates, because you might want to use different reporting formats for certain tests, so you define several report templates yourself. We have an EUT section where we define or store properties of the EUT, such as a test plan. So which tests do I want to execute for a certain EUT? Properties of the EUT, attachments like manuals, data sheets, certain instructions for the operator. Also, we need quite many tables, and tables are of course pretty important because tables give us the details of, let's say, an antenna, the characteristic of an antenna, characteristics of a cable, of the amplifier. We can have frequency lists if we don't want to measure the whole frequency spectrum. And of course, reference calibrations for EMS tests. These tables are all used in the test setup or a test template. And I have already imported some of the test templates in Electra from our configuration wizard. The configuration wizard contains quite many predefined tests according to most common specifications. And I've selected already some of them and imported them. So you just click on the relevant standard you would like to execute, press Finish Execute, and you automatically receive a few templates for these tests, which are already ready to run. You don't have to touch anything. Most probably, they won't start in the actual situation because there are two things we have to do. We have to apply the right instruments because in the test setups there are sample instruments, and if my test template is set up with a ESW44 and you don't have an ESW44, we will have to change that. But that's a pretty easy task, and I'll show you that in a minute. Also, we have to define the calibration tables, of course. You have to just simply add your calibration tables for the cables, for the antennas, transducer factors, and then you can basically start with your testing. Okay, difference between EMC32 and Electra. In EMC32 we were using a file system to store all our data. In Electra we are using a database. And the database is always backed up automatically. You can do manual backup, so whenever you want to try out something, just try it. You can at any time go back to the last backup and you're fine with your setup. You can easily install several versions of Electra on one PC. and you can install it in parallel to EMC32. So you can do a smooth transition from EMC32 to Electra by transferring only few tests one by one without any hurry. You can work with the EMC32 in parallel, not at the same time, but on the same computer, while you are transferring the data to Electra. If you have several Electra desks in your lab, like let's say one for the BCI test, one for the anechoic chamber, we can share the database of Electra between several installations or several workplaces. And in my case, I use a standalone Electra instance with its own database, but you could also just have a remote Electra and use the database of another Electra installation on another PC. That allows you to simply make sure all the data is there and it's correct. You don't have to synchronize all the files and directories. This is then done basically automatically. We can assign users and roles and groups, so we can determine who has access to which functionality. And you can basically assign your users to the operator group, the expert, or the administration group to make sure no data is lost or accidentally deleted. Okay, let's start with the test templates. You see that all the test templates are stored here in one list. That's also a difference to EMC32. That means we have a flat list here. We don't do subdirectories and tree structure here, but for every item, you just add keywords. So you insert tags and keywords, and so that everybody can easily find it by just searching for this item or for this keyword. There are some predefined keywords in there. So I could easily just click on one and I receive the result. So I can very quickly find in this flat structure my relevant items. And that works for test templates, for hardware setups, for the device list, more or less for everything. In EMC32, you would now go ahead and start with a device list. To create a device list, you would then add a hardware setup, would then add a template, so build it up from bottom to top. In Electra, we can do also the same way, but you can also just start with a test template. Just open one of the templates, which I already pinned here to my desktop, because I would like to use it very often. So I go to the dashboard, and I have the most commonly used items here directly on my dashboard, which gives you also very quick access to the data. Let's open this EMI test here in edit mode. Now I can define the test template, that means the workflow, but also I have access directly from the template to the hardware setup and to the individual devices. So if I'm not happy with the ESW44 receiver, which is assigned here, I quickly unlock it and I change it. And if I find there is no receiver currently defined, I can add one to the device list, or I go a step back, let Electra search the network for available devices and then assign it to an existing device or create a new device. So very easy and quick way of changing the actual devices here in a hardware setup. Also, the same applies to correction tables. The measurement correction of my antenna. You see the tables are listed here. I can quickly go there, say, okay, I want to use another table. I create a new one, new transducer correction table, edit this table, import it, just drag and drop data or copy and paste data from an Excel spreadsheet or wherever I have it. And then I can use this transducer correction table in my test. I go back to the previous one. Right. In EMI, especially for automotive, I can use overlapping frequency ranges. That's a new feature here in Electra. In EMC32, that was not the case. So whenever I have to use frequency ranges for certain communication bands, FM, DAB, and so on, I can define that in my template as a sub-range. Over here, I can add a new one. And these sub-ranges can be overlapping. So that makes life much more easier when it comes to these band evaluations. I see the workflow on here for my EMI measurement. The overview measurement, the data reduction, and the final measurement are being executed at the moment. When I click here on overview measurement, I get the details of the overview measurement down below here. If I go to data reduction, I get details of the data reduction, and the same for my final measurement. Let's stay with the overview measurement. I define my detectors I would like to use, and for my frequency range, the hardware setup, the limit lines that are being applied, and of course define all the details of my spectrum analyzer or my test receiver. We do not distinguish here between sweep and scan and automotive and non-automotive templates. It's all the same. You can decide later on in the template if you would like to use a spectrum analyzer or if you would like to use a receiver. Once we have configured this and once we have configured the data reduction, so there are several ways for data reduction, even here a custom data reduction, so you write your own code to reduce the data to the critical points. And the final measurement, once this is done, we are basically ready to start the test. I quickly switch on go to the overview measurement and quickly change here the accessory settings, because we're using a turntable, we're using a mask with a height change. So I do only 180 degrees here because we would like to speed up the execution of the test here in this demo. We step the height scan, we skip that, and polarization we just do, let's just do the vertical polarization. There's a user-defined loop which you can use for switching in the device, to use several modes in the device maybe, if you would like to do that. So this user-defined loop, that's depending on your requirements. Let's save that test. Now let's go quickly back to the EUT. I mentioned that we have a EUT management here. I have created already a new EUT. Could be any type of component of a car. And I can simply add information to that EUT. General information, attachments, possible errors that can occur. I added already one here, that's the display defect. Let's say in an EMS test we expect that a display turns off. Then I can already define that here in advance, also later, as a defect. Attachments, I could add some data sheets, handling instructions or manuals for the operator. And of course, any type of information can be added, and this is also, of course, available in the report. Let's go back to the test plan. Let's create a test plan for that EUT. So I add a new folder, and in this folder, I could add subfolders, which I don't want to do now. Add a listen test, add a BCI test, add a field strength test. And all of these tests, I can give them a name, assign a name to this test, and I can simply define the test in here. So which test template, which report template I would like to use for this, exactly this test in combination with the EUT. That can be different for another EUT, of course. Okay. I quickly delete that because I don't want to execute a test plan. I just execute the test directly from my test plan. And you have seen I've opened the test template. I have the EUT definition open. I could open a hardware setup, and I can easily switch back and forth without closing and opening windows. I can drag that tab from the window and move it to another screen. So I can easily use several screens, several resolutions to keep the overview on what is happening. And even if I run a test, I can go back to test templates, modify templates, work on hardware setups, work on reports while the test is running. We would like to execute a test now. One thing I haven't shown is that we have typically in such a test, that's an EMS test. We skip that and do that in the EMS test. So save the test and start the test. So you will see another tab popping up. Quickly do some auto scaling here. My two limit lines, one for the peak, one for the quasi-peak detector. You see the test components, that's all the files or data that is being used during the test. The measurement flow, which we are stepping through, is shown here. There are some additional controls on the left-hand side here. Everything can be reconfigured on the screen, so you can adapt it to your needs. You can detach it from the window, put it in another screen. So that's totally customizable here. Here's the frequency control, and finally afterwards our evaluation control, which we could use. Let's go ahead and simply start the automatic execution now of this test. I can switch here between automatic and manual, interactive execution or automatic. So I start the automatic execution. We are doing some checks on the data. Is the data valid? Is the data available? And in my setup here, the Electra detects that there is no instrument connected, no receiver, no antenna tower, no turntable. Okay, in my case, I do a simulation of these instruments. Now you can see on the left-hand side that we are stepping through the turntable positions. Okay, we have only one polarization. We do a data reduction, which was pretty quick now. And now we're moving the turntable, which you can see here, to do a final measurement. We have identified, now we're done. The test has passed, so we have identified critical points. That's the critical points list. 2 frequencies where we are close to the limit. And on these frequencies, we did a final measurement with the quasi-peak detector. And we found out that also the quasi-peak detector has exceeded these limits. So we basically have a test which is failed because at 2 frequencies we exceeded the limit. On all of that, I can simply create a report now. PDF, docx, whatever is preferred. That's the predefined test report template with the graphics and the results. I could now just add some other information to my report. Let's say the hardware setup. Do a quick update, and not here, but on page 2, I get the details of the hardware setup. I could add some additional information, type in stuff. So that's pretty customizable. If you want to be more flexible, even like that one, there is an option to allow you to define your report directly in a Word template with XML code, and this XML code is then replaced automatically by the data once you tell Electra to update this template or update the report. So that's the simple execution of an EMI or EMI test. Let's go to an EMS test and see how an EMS test looks like. Check the templates, search for an EMS test, or I guess this is an EMS test. So let's see how a BCI test would look like. Again, we have some general settings. First of all, the automotive standards being selected. Then I selected here a qualification test. That means we apply a certain level, immunity level, and check if the device is still working. I could also go to susceptibility, which means we find out at which level the device is failing. So we search for immunity level, while here in the qualification we have defined a certain immunity level. Also, reference calibrations, amplifier tests can be selected. We also have calibration tests in there to calibrate your cables and so on. In an EMS test, I typically use a monitoring. As mentioned, I have to check if the device under test is still working while the immunity signal is being applied to the device under test. And this monitoring can be a manual monitoring, so I simply watch the device. If I see it fails because some lights turn off or something happens, then I just press a button and say, okay, at this frequency now the device is not working anymore. I can automate that. Typically I would use measurement equipment to monitor the device under test. That could be oscilloscopes, that could be power supplies. So if there is no current drawn from the power supply, obviously the device under test is failing. In automotive, you typically use the CAN bus to monitor the device under test. So if there is no communication on the CAN bus or LIN bus, several bus types are supported. If there is no communication anymore, or if the communication shows errors, you receive the device on test failed. And with a monitoring template, I can define such a automatic monitoring. I have some pre-configured. The one is the Advice. We have an additional software called Advice, which is a visual monitoring software. This software uses a camera to watch the device under test. And if lights start to show up, like a warning light or a blinking light, or if indicators move, or if there's a stop of movement or something like that, there are pretty many methods of evaluating the picture. If something happens in there, we automatically can create an error in Electra using this Advice software and a camera. So you don't have to constantly watch the device. And also I've configured the EM-CAN. That's a separate tool. EM-CAN is a tool that comes with the Electra Automotive option. EM-CAN builds up a communication between Electra and the very commonly used vector CAN-OE and CANalyzer products that are being used to simulate the CAN bus or to evaluate the CAN bus. So with EM-CAN, quickly switch over, tool, we can connect to the CAN-OE software or CANalyzer software. Here, we can retrieve all the elements or the data, the variables, the signals that are sent over the bus, and select these signals as the monitoring signals, like the speed of an engine, speed of the wheels, whatever is available on your CAN bus. Then we can apply already here some limits or thresholds and say, okay, if this value exceeds the permissible range, there is an error, and then the EM-CAN will automatically trigger Electra and say something happened in here. You can also communicate in the other direction. We can send some data to the CAN bus if this is necessary. So we can send, for example, the immunity frequency, the immunity level, the modulation we apply to the signal, the dwell time, things like that. We can simply put on the CAN bus and you can evaluate it in your CAN tools. Alternative. Good. So that's the monitoring of a device and the test, of whole vehicle or component. The measurement flow is a bit easier in EMS than in EMI, because we just go through the frequencies, detect if there is an error, and that's it. The settings, we have two frequency ranges now in our example here, 1 MHz to 10 and 10 to 400. Step size, test levels are different, dwell times are set, and the modulation. So we have a modulation sequence. So we first try without modulation, then we add on the modulation, and this is already available here and automatically executed in Electra. Leveling or defining the immunity level, that's a bit special in automotive. That's different to the commercial measurement methods. We level here on the sensor, which is the sensor clamp, which is being used in our hardware setup. Let's quickly show the hardware setup. So we have a generator, the amplifier, injection clamp, and a monitoring clamp with a sensor behind the monitoring clamp. So we level on the sensor. We use the forward power, which is being measured here with a forward power sensor. As a power control, leveling options, we do the modulation peak or modulated carrier. So that's different ways of adding the modulation to the carrier. We can add some power level limitation for safety or sensor level limitation. So we do not exceed a certain level. Within our frequency range here, I can also set the test level like a constant level, or the level is here defined by a table. Let's take a quick look at the table. Okay. Table is pretty simple, a straight line, but of course could be a level. The level could be changing through across the frequency. The level profile, so typically when we move from one frequency to the other frequency, we can just simply apply the target immunity level, but we can also, and that's common to these automotive standards, you step down first a few dB and then you slowly step up again. And this I can define here to step up, step down my immunity signal, or also add some blanks. So I switch off the immunity signal for a second and switch it on again. Let's take a look at it's on the other screen now. To find my mouse, go back. This is how the immunity level looks at the moment with my configuration here. So we come here with 0 dB, we step down minus 10 dB, then we step up again and step down again. That's how it's defined in this test. Of course, we can change this here, quite simple. The modulation list, that's I mentioned we have two modulations we would like to use. So we start without modulation and then we do a 1 kHz 80% amplitude modulation afterwards. Device settings, yeah, I can click here and set my devices similar as we did in EMI. I simply click on the item or the device, choose another generator, for example, or change the settings of this generator. All right, accessory settings. Yeah, we do go through the modulation loop and we go through the frequency loop in this case. Again, we have a user-defined loop which you could use. So let's run this test. It automatically shows all the points in our test system which we want to monitor. Of course, we want to monitor the test level, the forward power, generator output, and here we have two signals. That's our signals we retrieve from the CAN bus through this additional CAN monitoring tool. In my simulation, I do not have a CAN bus connected and a CAN analyzer tool connected, so these will be switched off and I manually apply some arrows. So let's start a test. Again, we do go through our validations and simulate the equipment. So in the generator control, you can see that we are stepping up from the frequency. Start at 1 MHz, now we're at 1.2. And here in the test level, you can quite good see that we are ramping up at every change of frequency. We are moving, stepping up the immunity level to our target level. The target level, test level is shown here. Forward power generator output is shown here. And these are simulated signals from the CAN bus. So now I just apply an error and say, okay, boom, my device doesn't work anymore. The process is stopped. I can apply a certain error code, failure mode, or define a new one on the fly and say, okay, now the display has been switched off. Let's continue. Noted there's an error or failure of the device. And let's continue with the next frequency, step through the device one by one. And you see here that the failure has been recorded automatically with the cause display has switched off, for example. So you see here that we're switching off, on and off the modulation. So we run a test without modulation. We run a test with AM modulation. And I think we stop the test now here. So again, we get our results, the result table, final results, and the final results. Critical point, sorry, we haven't done a final result yet. We skipped the final result, but the critical point, display defect, which I have acknowledged here manually. I get all the points shown here then. Again, I could create a report now from that test or watch the graphics and do some post-processing. Add a report. Yeah. My template is pretty empty, but again, I could show the error causes, could show the target level directly in this report. So this is how Electra works for EMI, for EMS. There are a lot of different aspects when it comes to testing, a lot of details that can be discussed. This should be a general introduction on automotive and Electra. So I think you should have gotten a good overview on how Electra works and how Electra can be used for automotive EMC testing. There is a demo version available of Electra. So just download it from the Rohde and Schwarz homepage, and very important, ask for the unlock key, for the personal license key. With that you can enable the full demo version and try yourself, as I did here, in a demo setup without real equipment, but with simulated data. If you have further questions, don't hesitate to contact your Rohde and Schwarz representative. Thank you for watching and see you soon for the next presentation.